Okay, you should have 4 different pieces of paper. Doesn't matter what color they are, but 4 different pieces of paper. Okay? I want you to line them up a little bit so that there's approximately the same distance between each. And then you're going to fold it like this. Not all the way though, please. Okay? Not all the way right here because you got to have, see how there's 2 right here? Okay? I need it back on. Okay. Okay, so you see how it looks now? It's so beautiful. All right. On the very top flap, oh, sorry, after you do this, we're going to put some staples in the top, either 2 or 3, whatever makes the most sense to you, whatever makes you feel secure, I guess. Okay. On the very top flap, we're going to title this Exponents. It's totally up to you how big it is. Okay? Okay, so I'm going to staple mine real quick. I like 3 staples, so I'm going to put 3 staples in. But it does not matter. Okay? So we have our exponents foldables. Now we need to fill in some information. You ready? On this very first, the very top flap is just the kind of like the title. Okay? The next flap, we're going to write product of powers. Product of powers. Now, as a reminder, this exponents foldable is just a review. We're just adding those fractional exponents that we talked about yesterday. Okay? So a product of powers looks something like this. A to the m times a to the n equals what? When we're multiplying like bases, what do we do with our exponents? Add the exponents, right? Like that. Okay? Everybody okay with that? So now what I'm going to do is I'm going to fold this first flap up, and look, I have all this room for some notes. Isn't that exciting? Of course it is. X squared times x to the third equals what? Whoa. X squared times x to the third equals what? X to the fifth. Multiplying like bases, we add our exponents. So now we need to have one more example. Something like x to the 3 halves times x to the 4 halves. I know 4 halves is 2. Give me a break. What's that going to equal? X raised to the 7 halves. 3 halves and 4 halves is 7 halves. Does that make sense? Good. We're done with that flap. That one's not hard, is it? Okay. On the next flap, we're going to write power of powers. This rule looks like a to the m raised to the n power. And what do we do with those exponents? Very good. Multiply. So we end up with a to the m times n. Okay? Preguntas? No questions? Okay. So let's fold up this flap, and we have some more room to write some notes. X squared raised to the third. X to the sixth. Very good. Okay. Now, just as a really quick reminder, okay, isn't x squared to the third power really x squared times x squared times x squared? And then can't we use the product of powers rule and add our exponents since I'm multiplying like bases? Guess what I get? X to the sixth. Okay? We didn't talk about that yesterday when we talked about this, and I wanted to just remind you of why the rule is the way it is. Okay? We good? Okay. So what happens if we have x to the 1/2 power raised to the third? What do we do with these exponents? Multiply. What do I get? X to the 3/2. Okay? If I start with fractions, I want to end with fractions. I don't want to jump to a decimal. Okay? Everybody clear why this is true? Just a real short. If you're not clear, write this down. If you are clear, don't worry about it. But what we actually have is 1/2 times 3, right? Which is actually 3 over 1. When we multiply fractions like this, we get 3/2. Okay? We good? Okay, our next tab is power of a product. So this means if I have A times B and I'm raising that to the n power, what's actually happening? Very good. I'm raising everything inside of there to the power. A to the n, B to the n. Okay? So let's fold up this tab and give ourselves some room for some notes. So let's start with something pretty simple. Let's say AB squared. So what's happening to both A and B? Perfect. A squared, B squared. Okay? What if the things inside the parentheses, though, already have some exponents on them? So you would end up with x to the 8th, y to the 12th. Very, very good. Are you guys just really good at remembering these rules? Or are you just being geniuses today? Or could it be both? Both. Okay, good, good. Okay. So now I'm going to throw a wrench in. You ready? Two x y to the 5th raised to the 3rd power. Are you going to let me trick you? Okay. So what goes first? Why 8? It just says 2. Oh, everything is being cubed, right? Not just the exponents, but the actual numbers in there. So 8x to the 3rd, y to the 15th. Excellent. Do things change when we have fractional exponents? A, B to the 1/3 power. Perfect. A to the 1/3, B to the 1/3. Very good. Ooh, I'm going to try my hardest to trick you right now. Are you ready? Okay. (16) a to the 5th b raised to the 1/2 power. So I think we're all pretty clear that everything inside is being raised to the 1/2 power, right? We got that, okay? So what goes first? It's not 8. We're not multiplying 16 times 1/2. Samantha, you never let me trick you. Why? Tell me why it would be 4. 16 to the 1/2 power. And if you'll remember from yesterday, what does it mean to raise something to the 1/2 power? Square root. Very good. So the square root of 16 is 4. Okay? What about this one? A to the 5th raised to the 1/2? A to the 5/2, very good. B to the 1/2, excellent. I'm going to have to try harder to trick Samantha next time. If you got tricked, that's okay. It's just something to work on, right? It's not a mean trick. Do you need some tissue? Okay. Okay, so the next one. You ready for the next one? Next tab. Quotient. What does quotient mean? Dividing, right? Very good. So if I have a to the m divided by a to the n, if I'm dividing like bases, what do I do with the exponents? Subtract the exponents. So a to the m minus n. That's okay. I still remember what quotient means, and so I want you to remember it as well. Okay? So let's go and fold this up so we get some note-taking room. Quotient of powers. X to the 5th divided by x to the 3rd. Oops. Yeah, x squared. X to the 2nd. Okay, I'm going to try to trick Samantha again. X to the 3rd divided by x to the 8th. You are not Samantha. You got the same thing? 1 over x to the 5th? How come you didn't write x to the negative 5th? Because 3 minus 8 is negative 5. Okay, so we can go the negative exponent route. Most people don't like negative exponents. In fact, most people hate them. But they are a fact of life, so we have to deal with them. Okay? Or, remember, we can just think of, let's start where the bigger exponent is. What is 8 minus 3? 5. Leave it where you started. We started in the denominator, leave it in the denominator. Okay? Does that make sense? Does anything change when we have fractions? Everything changes. X to the 4/3 divided by x to the 2/3. X to the 2/3 because that's what the denominator is, so I just rewrite the denominator. They have like bases, so we subtract 4/3 minus 2/3 is 2/3. Okay? Next tab, you ready? Power of a quotient. Anybody know what quotient means? Oh yeah, divide. Good job. So if I have A divided by B, and that's being raised to a power, what's really happening? The numerator and the denominator are both being raised to that power, aren't they? Very good. Oh, sorry. Yep, I will. Got it? Okay. So again, we want to start off really simple. X divided by y to the 3rd power is the same as what? X to the 3rd, y to the 3rd. Very good. Very good. Okay. Does it matter if the things being divided already have exponents? What about this? A to the 6th power divided by b squared, all being raised to the 4th power. A to the 24th, or b to the 8th. Very good. What about this? That is a z, yes. Do not make fun of my z's. Whatever. Sometimes, let me find the paper real quick. Sometimes I just get excited about doing my math, and I'm just like, 2z plus 5z plus 6z. What's a 2 and what's a z? Right? Like, I'm so excited to add all these up, I don't know what I'm writing. So sometimes I write my 2 like this. I try to write it like this, but it doesn't always happen. But my z's, I always put a line through the middle, so if I'm going fast, you can tell it's a z. Okay? I do have a good reason. So what's the answer? 9x squared over z to the 8th? Genius. Good. Does it change when there's fractional exponents instead of whole numbers exponents? What if they're ugly fractional exponents, like 5/7? Yeah. X to the 5/7 over y to the 5/7. That's it. One thing I will caution you on, though, guys, it's harder to write fractional exponents than it is regular exponents because it takes more room. Okay? So be real careful that you don't mistake this for a multiplier because you wrote it too low. It is a superscript, right? In computer language, I think they even use that in chemistry too, don't they? Superscript? I know they do subscript. I don't remember if they do superscript in chemistry. They do? Okay. So you got to make sure it's a pi, an exponent. Okay? Last one. Last little tab. Well, not really last, but the last one we're going to use. It just says negative exponents. A to the negative n power equals 1 over a to the n. We even talked about that just a minute ago, didn't we? A little bit. Okay. You got this? Okay. Okay, thank you. So if we have x to the negative 3rd, I think by now we've kind of gotten to the fact that we know that's really 1 over x to the 3rd, right? Especially after yesterday. Okay? But what happens when it's a little bit more involved? What happens if it starts here? This started in the numerator, and when we moved it to the denominator, it's not negative anymore. Where is this starting? In the denominator, so where do we want to move it? To the numerator, and when we move it to the numerator, it's not negative anymore. Do I have to have over 1? Can I if I want? Okay. What about this? What if I'm just asked to simplify a problem like that? Negative 2x squared y to the negative 3rd. This is another place where I think vocabulary has gotten us in trouble, so we're going to work really hard today to fix it. Okay? But why didn't we move the negative 2 to the bottom? It's negative, so it wants to go to the denominator, right? It's not an exponent. This only is working when they're negative exponents. That's why we called the tab negative exponents, right? So the negative 2 doesn't move to the denominator because it's just a multiplier, right? It's just a constant. X squared Nothing's wrong with it. It doesn't have a negative exponent. It stays where it is. The only thing that moves down to the denominator is the y, because it has a negative exponent. But when we move it to the denominator, it's not a negative exponent anymore, is it? Okay. So one more problem that can be tricky if you let it. So how about if we just not let it? Is that okay with you? Okay, so what if it looks like that? 3xy squared raised to the negative fourth. How many different ways can we do this problem? Like 84? Not really, I'm just made that up. At least 2 for sure. Okay? Do we want to take care of the negative exponent right now? Or do we want to use our rule like this one and distribute that negative to everything inside? Or sorry, distribute the exponent to everything inside. Most people find it easier to get rid of the negative exponent first. Okay? How do we get rid of this negative exponent first? Everything that's being raised to the negative power gets moved where? To the denominator. And when we move it to the denominator, it's not a negative exponent anymore, is it? And now we can distribute that exponent to the exponents inside. So we end up with 3 to the fourth power, which is 81. X to the fourth power, which is x to the fourth power. And y squared to the fourth power, which is y to the 8th. Does that make sense? So tell me again how everything changes when we have fractional exponents. So x to the negative 1/2 power. That's really the same as 1 over x to the 1/2 power, right? Have I made my point that the rules don't change when we have, just because we have fractional exponents? Okay. One more just to make sure we're okay. 1 over x to the negative 3/4 power. What's that going to end up being? Very good. X to the 3/4 power. Okay. Now we do have a last page. Okay. We do have this whole last page right here. We're not going to waste it. We're not going to draw pictures of sticks or rocks. Yeah, I'm sure. We're going to remember. This is just going to be a little page of notes for ourselves. Okay? So first thing I want is this. A to the m over n power. Okay? A to the m over n power. And what I need you to remember is that the top is the power and the bottom is the root. Remember yesterday how we said raised to the 1/2 power was the square root? First power, second root, square root. We also talked yesterday about to the 1/3 power. 1 is the power, 3 is the root, a cube root. Does that make sense? Mm-hmm. We'll get there. We'll get there. Yeah. Well, how about if we just go there now? Just as a small example, if I say 9 to the 3/2 power, I don't need a calculator for that. I know the top is the power and the bottom is the root. What is the square root of 9? What is 3 cubed? 27. What is 8 to the 4/3 power? What is the cube root of 8? What's 2 to the 4th power? 16. How about this one? This one's ugly. 7 to the 2/3 power. What root is it? The cube root of 7 squared. Okay? Now, I had quite a few questions yesterday, enough questions that it made me uncomfortable about this. X to the 0 power is 1. Okay? I talked to Mrs. Patton because she's nice and she's my friend. Right? And I said, I've got kids who do not understand that anything to the 0 power is 1. And she said, did you show them the area model? And I said, no idea what you're talking about. And she said, can I show you the area model? And I was like, I would love to see the area model. Okay? So let me see if I can help this a little bit. Okay? By showing you an area model. Do you know what I mean by an area model? Like blocks. Like if we're having blocks. Okay? So tell me what 2 to the first power is. It's 2, right? So if I have a block, 2 blocks, it would look like that, wouldn't it? Okay? Well, what is 2 squared? Wouldn't I just take this and double it? So it would be this and this, right? Now, what shape is that? A 2 by 2? It's a square, isn't it? What shape is this one? 2 by 1, that is a rectangle, right? Okay, so what's 2 to the third power? I didn't give myself a lot of room here. I add another set of cubes, right? So I have that. I multiply by another 2. If I'm multiplying this by another 2, I double it, don't I? So what about 2 to the fourth power? Don't I double this? So what I had was this top one, and then I double it, and I get this bottom one. So this was 2, this was 4, this was 8. What's this? 16, right? What if I want to go the other way? Think about it. What shape is this one? It's a rectangle, right? What shape is this? A square. What shape is this? Rectangle. What shape is this? This is a square. It's 4 by 4. I didn't do a very good job of drawing it, but it is a square, right? Okay. So do you see a pattern here? Rectangle, square, rectangle, square. If I did the 2 to the fifth power, what shape would it have to be? A rectangle. So what if I'm going the other way? What if I do 2 to the 0 power? How did I get from here to here? How do I get from here to here? Here to here? Aren't I taking half of it? Well, what's half of 2? 1. What if I go here? Aren't I taking half of it still? If I take half of this block, what do I get? Half. Right? This is 1. This is a half. What if I go one more? 2 to the negative 2 power. I'm taking half of it again, right? What's half of a half? It's a fourth, isn't it? But it still follows the same pattern. Square, rectangle, square, rectangle, square, rectangle, square. Does that help at all? Okay. We could do 3 to the first power, or 4 to the first power, or 5 to the first power, but still what's happening is when I get to the 0 power, it's just going to be 1 cube. Because if I do 3 to the first power, how many do I have? 3. If I do 3 to the second power, I'm multiplying by another 3, right? So I get 3, 3, 3, right? Rectangle, square. What am I going to get when I do 3 to the third power? I'm going to get 29 blocks. I don't want to stand here and draw 29 blocks for you. Or 27 blocks. Sorry, 27. Okay? But what if I go the other way? I was at 27, then 9, then 3. Aren't I dividing by 3 every time? So what's 3 to the 0 going to be? 1. Because 3 divided by 3 is 1. And if I go 3 to the negative 1, I need just like, oh, that's not good. A third of it, right? Ignore that part. I get a third. Does that help? I hope it does. Okay? Any questions about this? If I were you, wink, 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 I would right now turn it over to the back and write your name on it. Don't write Mrs. Kingston. That's my name. You write your name on yours. Okay? Because you might, wink, 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 want to have it around during the test. And if you have yours, you will be able to. Okay?